I get to introduce Vincent Grossi. Vinny is not from New York. Vinny is from Arizona. Vinny's been here, this is your 4th year at the college.
Yep.
Vinny will be graduating this year.
Yep.
And Vinny has worked a couple crews. Vinny's been on the Bonner Leadership Crew through community engagement, and Vinny has also been a stalwart on the farm crew. I've never had Vinny in a class, but here's a note for all you incoming students and new students. You want to work yourself into a position where you're the person where a professor says, oh, I've got a really cool project and I know who can do it to the end. Right? That's Vinny. This project is a great project that we developed a donorship relation with a fella in Georgia that we really appreciate his generosity. And he decided to donate money to get at a very important project looking at soil carbon at our farm. And as soon as the project came up, I knew Vinny was a student who could handle the job. Vinny's taken it to fruition, and I want to let Vinny give you the project now. So take it away, Vinny.
Thank you very much for the introduction. It's with pleasure that I present my answers in establishing the baseline stocks, as Dave mentioned, baseline carbon stocks for this Ferguson Soil Carbon Project on Warren Wilson College Farm. I'd first like to start with just a brief land acknowledgement. This research hinges on land stewardship, and from that perspective, it's important to acknowledge that Warren Wilson farmland is situated on the historic home of the people of the Eastern Band Cherokee. It's my hope that we continue to learn from their history and acknowledge their legacy of land stewardship here in the Swannoa Valley. So I'd like to give a brief timeline. I'll present some concepts that are associated with terms for measuring soil organic carbon. We'll apply that at a global context and then at an agricultural land management context, which will bring us to the context, the larger context of this project in relationship to the Warren Wilson farm and establishing this baseline. I'll present my design and methods of this baseline, and then I'll show you the baseline results, following a brief discussion of the application for this data going into the future, and then some acknowledgments for all the supportive characters that made this research happen. So first off, to cover some of these terminologies, I use Polson et al.'s research that kind of distinguishes important definitions across the terms that are used when measuring soil organic carbon. Soil sequestration is a term referencing when there is a net of CO2 that is sequestered into the soil system, and that amount succeeds the amount that is lost of SOC. At this point in time, for the sake of time, soil organic carbon I will refer to as SOC in the presentation. So when that is a larger volume than the amount of net loss due to cellular respiration. C stocks is a term that refers to a percent carbon concentration in relative to a volume of soil for a specific area of land. The common units are here, megagrams per carbon per hectare. C pools is similar to stocks, but it's a terminology that is used within modeling estimates to associate a kind of general amount of carbon within, say, a piece of the biosphere, or within inside different pools of carbon in the soil system itself. C sink or source. So oftentimes the C stocks and C sinks are misrepresented because in order to get an actual value of a C sink or a source, ultimately what that is showing is a change in SOC stock, in the value of the amount measured of organic carbon in the soil in that place of time. In order to get that change, you have to follow this, and this comes from the standard procedure at Ellert et al. That we followed for developing this baseline. It is the difference go ahead and ignore B, line B. That's for another treatment. But if thinking of your sample, your first sample time is 0, this is the point where we are. And this sample at time X, a long time, a certain recommended amount of years, that same spot is resampled. Change in SOC is the difference between the two. If that number is a positive value, that implies that there has been a sink of atmospheric carbon into the soil system. If that value is negative, that implies that that soil system has been a source of carbon CO2 into the atmosphere. Giving a little bit more example, we can kind of contextualize the terminology for sea pools in relation to our current global challenges with global warming and addressing rising CO2 levels in the atmosphere. Soil scientists oftentimes argue that soil sea sequestration is an effective plan and potential strategy for combating this climate change, based on the fact that, as I referenced in models, estimated models of soil sea pools, that value is greater than the estimated value for all sea pools in vegetation and the atmosphere combined. So essentially, that is implying there is more carbon in the soil than in all the vegetation and atmosphere combined. I'd like that to kind of sit in for a second, think about that. It's awesome. But in that process, we have to take into account that original definition of soil sequestration, which hinges on a larger amount of soil being sequestered in the soil than the amount that is respired out through cellular respiration. The process, if our goal is soil sea sequestration, the goal in land management is to maintain a living root, as this illustration shows, that is primary production, contributing and moving that carbon down into the soil system, and it feeds the soil biology, which undergoes a whole host of metabolic process, transforming that carbon from a soluble form that will get eventually filtered out of the system to further and further immobilizing it, stationing it, and storing it into the soil system. An emphasis has to be on reducing soil disturbance. Soil respiration happens from decompositions, the increased rate of decomposition, and that is oftentimes linked to soil disturbance. So this kind of brings us to an example of contextually looking at sea sources and sea sinks of whether or not a soil is able to hold that carbon in it can be seen from land management decisions. And specifically in our context, I looked at grazing practices and their impact on SOC stocks. It's important to consider grasslands when thinking about sequestration capability and the capacity. As this average shows, of that global sea pool, SOC pool, 20 to 30% belong to grasslands. And the rate of sequestration for those grasslands is determined by its usage and its management. Significant amount of these grasslands are utilized in livestock grazing. And the most recent up-to-date research is showing that there is an incredible potential for sinking carbon, converting from conventional standards of grazing patterns to managed intensive grazing. The first case study comes from 3 farms in the Midwest that, after switching to a managed intensive grazing, over a 7-year span in time, they were able to sink a net surplus of 8 megagrams of carbon per hectare per year. Second source comes out of Marin County in Central California, where UC Berkeley is working with ranchers and farmers to study the effects of amending rangeland using an outsourced source of compost. This study showed that with just a single application of 1/2 inch of compost across a treated area, it resulted in a net, after 3 years, in a net of 1 ton one ton of carbon per hectare per year. I'll just make a mention that I'm not contradicting myself. The study was clear to demonstrate that net surplus didn't come from the compost. The compost simulated the biological life of that rangeland, increasing photosynthesis and primary production of energy and transferring that into the soil system. So that's based on the rate of that recovered rangeland ecosystem. So, which brings us to our larger context here at Warren Wilson Farm. There has been a long history of change in management here at this farm. The farm is very old, over 100 years, I believe. But important to note, this document on the left was found in the Warren Wilson Farm archive, and it's dated. It's a letter that's titled Long Range Land Use Plan from 1998, which is significant that that was a handful of years before the farm switched to a more holistic management strategy and incorporated livestock rotation and intensive grazing practices. This plan had included in it, as stated in this list, the top priority was developing a grass-based rotational grazing system. That plan came true, and over the course of 20 years now, Warren Wilson Farm has been teaching students the importance and the value of all of these holistic management practices that include rotating crops, applying a break of crop cycle and returning it through a multi-species cover forage. This picture here illustrates the farm's fields. All the blue are perennial pastures. That perennial system never gets tilled, it's not disturbed. It remains with a living root throughout the year. The cropping fields are all rotated within this 5-year crop rotation plan. These are just some beautiful photos, which of course, kind of hard to see from the presentation, but of cattle grazing on one of those perennial pastures, dogwood. And this is a mix of livestock incorporated in a cover crop. This was just taken just 2 days ago of sheep on this dense, beautiful biomass of a cover crop in the back, and that's a partnership with the garden. So it asked the question, man, 20 years of this practice, there must have been a change. Well, we can't know. It's a question mark, because as originally established, we need a baseline stock value to be able to compare over time, which we don't have from the past. And essentially that's where this research is picking up. And thanks to our partnership with the Ferguson family, we were able to begin this research. So to describe briefly, and I'll go through, this is the beginning phase of designing this study. And it's important to just note real quick that this design needed to be sound and secure because it needs to be replicated when we go to re-sample later on in the future. So based on the literature's recommendations, we chose a non-stratified randomized design. That design was chosen based on the low level of spatial variance across the field sites that were selected. It's important to note that when the fields were selected through the research team and Blair, the farm manager, they wanted to consider 2 management practices, and so we included 2 perennial pasture fields, Big Berea and Charlie's, and 2 within inside of that 5-year crop rotation, which undergo a different set of management, dairy barn and back bottom. These fields were selected based on prior history of the management and potential change later on in management. The required number of samples was factored, luckily we did have some data from Mark Brenner's classes of percent C concentrations. Essentially, we took that data and we plugged it into this equation to factor for the level of variation with inside of the data that required, that showed us how many samples we needed to have an accurate representation. The standard depth that was chosen was 60 centimeters, and that was to consider the contributions of lower root systems from perennial species, carbon inputs, and those were broken up into two segmentations of an upper layer and a lower layer at 0 to 30 centimeters and the lower 30 to 60 centimeters. Sampling method, luckily because we had this funding for this project, we were able to purchase this Gittings soil sampler. This machine operates off of a hydraulic powered system, which one of the major advantages, because we wanted to extract such a deep core, it allowed for us to get an intact core at a deeper depth because we were using the power from the tractor. Additionally, as you can kind of see in the reference point here, the cores are big and beautiful, and it gives us a healthy amount of sample to then take an analysis, a representative sample for the analysis. Additionally, a larger core, when it comes to measuring soil organic carbon, a big piece is the bulk density, and this allowed for us to gather an easier process of gathering the bulk density for this size core. So I'll just go briefly into the methods of the study. Essentially, I took the randomized points from QGIS. I found the coordinates of those points. I went out with a handheld GPS. I flagged all of those points. I then came back to those points with the Gittings and the tractor. I followed a standard procedure in operating the Gittings to extract those cores down to a depth of desired depth of 60 centimeters. I noted all of the important features at the time of recording these cores, including the weather and time and other conditions. And also I measured the depth of the hole to account to make sure that the sample, there was no major compaction or an issue that happened obstructing the soil core. I took all these samples back to the lab. I divided the soil cores based on our desired segmentations. I obviously extracted them from the casings and recorded the measurements. I recorded all the wet mass of those segmentations, and then laid them out for air drying process. We came back to that process about 5-6 weeks later, recorded the dry mass once they had successfully air dried. I recorded the dry mass and recorded the dry mass, and what else did I do? A whole bunch of things, okay. Then I conducted a month-cell color test, just briefly, with a handful of samples as representative per field. I also conducted a soil texture by field. And following that, I homogenized the samples with a standard pestle mortar. I grinded them all down to pass through a 2mm sieve. And once they were fully homogenized, I took a small representative subsample and recorded that. And all those subsamples were then collected, and they were brought to the Central Appalachian Stable Isotope Facility, where they were analyzed using dry combustion method, which is a CH analyzer that tests for percent C concentration. I won't let anyone fall asleep at this point. Obviously, this is a lot of things going on. I'm not a math major, I'm a sustainable ag major, but essentially what we had to do is take that percent concentration and apply it to that segmentation. The amount of the volume of soil is also connected to the fixed depth. And so we needed to record that. We needed to gauge the SOC stock value based on that fixed depth. So this is the sum of the two segmentations products of this formula. And that got our SOC at fixed depth. And then we created an aggregated mass of that by doing the same procedure of the two segmentations products together. And then in order to avoid the bias that's created by the different masses of the samples, we then extracted the recorded lowest core. Extracted the recorded lowest core segment mass from all of those masses of SOCFD. From there, we were able to include that as the excess mass to be removed, and the final SOC stock to a fixed mass equation is below here, times by the concentration of the lower segment within each core sample. And the 1,000 is a representation of the spatial area. So here is our results. I imagine there will be some questions, maybe from professors. If you can interpret the data just based on what it is, what it's showing, there is a wide level of variance, obviously variation in the data. I'll just make one brief note that Dairy Barn with sample 135 was an outlier. That value was extremely higher past any of the other values. And it was also followed back all the way to the percent concentration from the lab's work. Anything else? That's good. So we had no reason to expect that there would be or would not be significant difference between these fields. That SOC stock stands alone in its value, and it has no reference to the future or predictions of Y. But based on that variation in this data, we did go ahead and run a statistical analysis using standard ANOVA with a normality assumption test. We did pass the normality assumption test, and there was a significant difference. This is a box plot showing the higher and the lower and the third and the quartiles and the median in between. And there was a significant difference between back bottom and dairy with a p-value of 0.02. So in discussion, the applications for this data, in the future, we will be able to take this and apply it to potential land management practice, changes in land management practice. Those could include incorporating a no-tillage practice or reducing the level of tillage that is practiced on the farm. Additionally, any change in grazing management strategies could also be applied to this data. Likewise, we could incorporate regional climate trends and associate any changes in carbon with changes in our local climate. But this is really nothing without new NSURS students to come after me, come after this project. Please join us because we need more data. And if the research team decides, more field sites could be collected for their baselines. And then based on literature, because soil grows slowly, next 5 years or more, we could establish a new set of data from the same spots for a change in SOC stocks. So, and then lastly, I'd just like to acknowledge the Ferguson family for their generous funding of this research. It's made it possible. The entire research team and my committee, Mark Brenner, Dave Ellum, Jay Cagthorne, who was going to be here but had to watch his kid, and my NSURS advisors, and of course, like a classic NSURS project, I had multiple main advisors, Kim Borges, Joel Bostic, and Josh Arnold. Thank you for your support. And the farm management, Blair Thompson, Sienna, thank you for the tractor. And many thanks to all of my friends who gave their time and efforts in grinding soils to collecting cores, emotional, mental support, all of it. Very appreciative. So, and here's some soil samples.
Very great talk, and we have like 5 minutes for questions. Okay. Yeah, you go first.
Oh yeah. Oh yeah, you choose who goes first. Sorry.
Yeah, since I saw his hands
Great,
first.
okay.
Yeah, sorry.
Can you go back to the slide where you mentioned box plot?
Box plot.
Yeah. So the two larger boxes, are those the two non-crop fields? Two smaller, are they crop?
Let's see. Back, bottom. No, actually the two. This one, the two actually that had the significant difference were the crop fields.
And they were the higher C?
And they were the higher C values. Actually, yes, I believe so. Higher C values.
One time as well.
This one was high. This one was higher. Yeah. But the interesting thing was, what I have to still interpret is where exactly that came from. Charlie's. No, it came from Dairy Barn. That's what I thought. Dairy Barn. What was the effects of the outlier? So to still be understood.
All right, so Josh and then Lizzo.
See, go back to that box plot again, Vinny. So that second one from the left also had, it was not a significant difference.
It
but
wasn't.
it was also a fairly strong difference with the one on the left, which I can't see exactly what they were.
Which on what, back bottom, right?
Back bottom,
It
yeah.
was back bottom in Big Bria, and that was like at 0.07.
Yep. Also a pretty good result. So those two lowest ones, what you're saying is that one of those is from a perennial and one of them is from a rotation. And
The two
higher
lowest ones, one of them is from, yeah, Dairy Barn is the rotation, and Big Bria is the perennial.
No clear story there.
No clear story there, exactly. That was actually to my advantage.
I feel like the three of us are in a story arc of our questions, so they've laid mine out nicely. I'm wondering where back bottom and Dairy Barn were in the rotation when you sampled. I assume they weren't in the same stage of the rotation. Right?
Yeah, no, they were both, actually they were both in a cover in the multi-species forage.
And have they been for the same time? Okay.
Yeah.
Do you remember? They have, okay.
There's the farmer, yeah, yes.
Cool, thanks.
So I know this is a baseline, and the really sexy work comes later on when we get to compare over time. But I guess the question is, what's your hypothesis for where you'd see the most changes in the next 20 years given these management regimes? Do you have an idea of just off the cuff where you would expect to see the changes, the greatest changes? Where are we going to get the biggest bang for our buck?
Yeah, I mean, I would imagine Big Bria has a long history of being hayed. And I think that Blair and farm management are potentially going to hopefully get more cows and more of that rotational intensive grazing impact on that land that may show results. But also considering that we potentially will be looking into expanding or changing the tillage regime in the cropping fields, I would also imagine that those would show signs, especially since that sample will be taken over time. So hopefully, even if that process of conversion of practice takes multiple years to develop, our samples in the future, like on the scale of 20 years, I would think that will show big signs.
Nice, thanks.
Okay, the last one.
Last one.
All right.
Yeah, earlier slides you were talking about the experiments you've done in Marion County and Midwest.
Yeah.
You're saying Marion County was 1 ton C in a few years. is C like the element C, or is it, you stand, is C standing for like a carbon molecule you're using in the stand?
Well, C, yeah, so that is a stock value. So that is like relative to this, because it's all based on the same procedure of sampling. So it's a C concentration based on that specific mass of soil in relation to that area of land. So yeah, that's it is altered slightly. I can't directly, I'm not the best at explaining the process by which, obviously those equations, but from my knowledge, they used similar calculations to determine those values of those stock values. So does that answer it?
I was trying to ask, like, say carbon in the atmosphere, carbon's in the atmosphere is CO2. But CO2 is just the C is just a portion of the CO2 molecule, and it changes that ratio when it gets into the soil.
It
So
does,
there's
it
a
does.
change in proportion that's, I was just wondering.
And that's part of what's the complexity associated also with dry combustion method as well, because it just blasts it all, and it's not actually dividing into this specific separate pools and types of carbon that are in there, which have different shelf lives as well.
All right. So
Okay, thank you.
Next.